students, good morning. Myself Dr.T.Bhagya Kumar, Associate Professor, K.B.N College. This happy morning, I want to introduce the topic electrochemistry. That is in second BSc, third semester. Here, it is a branch of physical chemistry which deals with the relation between chemical energy and electrical energy, vice versa. Here, types of cells. Here, one is electrolytic cell and galvanic cell. Just now we talk about electrochemistry. That is, it is a branch of science which converts electrical energy into chemical energy and chemical energy into electrical energy. Electrical energy, by use of electrical energy, chemicals are produced. That is called electrolytic cell. Electrolytic cell. By using chemicals, electricity is produced. That is called electrochemical cell. That is called electrochemical cell. One is electrolytic cell. Chemicals are produced by using electrical energy. Another one is electrochemical cell. Electricity is produced from chemicals. That is, the best example is galvanic cell. The cell which converts electrical energy into chemical energy is called electrolytic cell. The cell which converts chemical energy into electricity, that is generation of electricity, is called galvanic cell or electrochemical cell. Here the major differences are between galvanic cell, that is electrochemical cell, and electrolytic cell. That means just now that is the cell, that is galvanic cell, that is the cell, a cell that produces electrical energy. A cell that drives a chemical reaction is called electrolytic cell. Here in galvanic cell, chemical energy converted into electrical energy. In electrolytic cell, electrical energy converted into chemical energy. Here the reaction is spontaneous. Here it is non-spontaneous. In galvanic cell or electrochemical cell, anode is negative. Why? Because it is a source of electricity. Cathode is positive. In case of electrolytic cell, anode is positive, cathode is negative. Here these are the major differences between electrochemical cell and electrolytic cell. Here measurement of electricity produced by coulometer. Here it is potentiometer. The best example for galvanic cell is presently used batteries. Here electrolytic cell examples: production of chemicals like sodium hydroxide, purification process, electroplating process is under the category of electrolytic cell. These are the major differences between two cells. One is electrolytic cell and one is galvanic cell or electrochemical cell. Here the first mentioned cell is galvanic cell and the other mentioned cell is electrolytic cell. Here we want majorly in electrochemistry, that is electrochemical cell, therefore which produces current. The best one is galvanic cell, that is constructed by using zinc and copper. Zinc rod dipped in zinc sulfate solution. Here zinc rod dipped in zinc sulfate solution. Copper rod dipped in copper sulfate solution. Both are connected through a copper wire. Both are connected through a copper wire via voltmeter, via current indicator, or simply you can put bulb here. Zinc rod dipped in zinc sulfate, copper rod dipped in copper sulfate. Here this is the construction of electrochemical cell. In between the two half cells, one salt bridge is connected. One salt bridge is connected to provide continuous flow of current, continuous flow of voltage. Here what are the reaction takes place? Here in this galvanic cell, zinc acts as anode. Why? Because it is a source of electron. Therefore the anodic reaction is zinc gives rise to Zn plus 2 electrons. These electrons are flow from anode to cathode. Here this cathode, at cathode, electrons are gained by Cu plus 2 ions from the electrolyte, forming copper ions. Therefore, for continuous flow of electrons takes place when these reactions undergo oxidation and reduction. That is electrochemical cell. Therefore, in previous years you might have already learned this topic. Therefore, that is enough for this. That is explanation. That is construction of galvanic cell. Here, next one, how we represent a electrochemical cell. For example, zinc and copper cell. That is here, left hand side anode half cell, right hand side cathode half cell. Both are separated by two parallel lines. That is salt bridge, indication of salt bridge. Here double vertical line indicates salt bridge. Oxidation half cell is representing left hand side, and cathode, that means reduction half cell, is representing right hand side. The single vertical line indicates the species are in different phases. Here it is solid, it is in aqueous phase. Here it is in aqueous phase, it is in solid phase. They are separated by single vertical line. Both half cells are separated by double vertical line, which represents salt bridge. This is here, the oxidation of half cell reaction is on the left hand side and the reduction reaction is on the right hand side. This is notation of electrochemical cell, the cell which converts chemicals into electricity. How this one be? This is the construction. Here, what is electrode potential? What is electrode potential? That means when a metal is placed in a solution containing of its own ions. When a metal is placed in a solution containing its own ions, that means zinc is dipped in zinc sulfate, copper dipped in copper sulfate. Then the metal may undergo either oxidation, that means loss of electrons takes place. Either metal undergo reduction, gain of electrons takes place. If the metal undergo reduction, the negative ions may be deposited over the metal, like this one. Here it is deposited. Here loss of electrons takes place, that is oxidation. Here gain of electrons takes place, that is called reduction. Here, what is electrode potential? That means when a metal is placed in a solution of its own ions, then the potential is developed either because of oxidation or because of reduction. That is called electrode potential. Here, what is the major difference between electrode potential? It is the potential of single electrode by connection with another electrode, that is called cell potential. Electrode potential, it is the potential of a single electrode, but it is a net potential of two electrodes combined. Two electrodes combined, then it is called cell potential. If the potential obtained by single electrode, that is called electrode potential. Single electrode potential cannot be measured individually. That means by coupling with another electrode. It cannot be measured individually, but it can be measured by voltmeter, cell potential. By using the formula, it can be measured by using a voltmeter. Here in single electrode potential, it shows the tendency to lose or gain the electrons. Lose, that is called oxidation. Gain electrons, that is called reduction. It shows the ability to produce current. That means both oxidation, reduction, and as well as oxidation takes place. Flow of electrons from anode to cathode takes place. That means we measure the current from this cell potential. Here it is electrode potential. Here it is cell potential. Don't confuse that one. Both are different. Electrode potential means it is a potential of single electrode. Cell potential means it is a potential of two electrodes combined. Therefore, how we calculate if the two electrodes are combined? By using this formula. This is cell potential, not single electrode potential. E cell equal to E cathode minus E anode. E cell is the overall potential of the electrochemical cell. E cathode is the reduction potential of cathode. In galvanic cell, copper reduction potential, that is at half cell reduction where reduction occurs. Half cell where reduction occurs, that is at copper in galvanic cell. Here at zinc, half cell where oxidation occurs in galvanic cell, that is zinc. That is E anode and E cathode. E cell equal to E cathode minus E anode, which gives the cell potential value. Here you might understand this topic, the difference between electrode potential and cell potential, how it is measured. Then this is also next definition is standard electrode potential. What is standard electrode potential? Electrode potential is, already we learn this by this definition. When a metal placed in a solution containing its own ions, the potential developed is called electrode potential. Here standard electrode potential means, here one term used as standard electrode potential. That means when a metal rod dipped in its own ions, yet pressure is equal to 1 bar, temperature is equal to 298 Kelvin. Here metal dipped in own solution at a temperature 298 Kelvin at a pressure of 1 bar. Therefore, that the potential developed due to these conditions is called standard electrode potential. Standard electrode potential. This standard electrode potential cannot be measured individually. By connecting with another electrode, which is called reference electrode, that is here from in this diagram, this is standard conditions. This is connected with one reference electrode to complete the cell, to complete the connections. We connected one standard hydrogen electrode, that is called measuring of electrode potential of any single electrode can be happened, that is by connecting with another standard reference electrode. Here standard hydrogen electrode is one of the important reference electrode, which gives the, when it is connected to another half cell, which gives this cell potential is arbitrarily fixed as 0. Here it is a reference electrode. The potential of standard hydrogen electrode is 0. Then it is connected to another half cell, that is metal electrode. Then by using the formula E cell equal to E cathode minus E anode, here it is acting as cathode. Somewhere it is acting as anode. Both are connected. The potential of the single electrode can be measured directly by using this value, by using the voltmeter value. Therefore, that is called standard electrode potential of, if you measure copper connected with hydrogen, measure zinc connected with hydrogen. If you want measure another magnesium metal potential connected with hydrogen. Therefore, for any metal, that means metal dipped in own ions at a condition of 298 Kelvin, pressure 1 bar, the potential developed is called standard electrode potential. This can be measured by connecting with reference electrode. Here reference electrode is what? Standard hydrogen electrode. Therefore, here this is measurement of one metal electrode. Here metal oxidation takes place. Hydrogen electron, this electron is taken by H plus ions, converted into half hydrogen gas, half into H2. Therefore, how it is constructed? Here the construction of standard hydrogen electrode. Here standard hydrogen electrode, it consists of a platinum wire. Here it is a platinum wire. In a inverted glass tube, it is inverted glass tube. Hydrogen gas is passed here from this side. Hydrogen gas is passed through tube at 1 atm. 1 bar and 1 atm are both are equal, just 0.1 difference. Through the tube 1 atm pressure, a platinum foil is attached. This is platinum foil at the end of the wire. This is platinum wire. Platinum foil is attached here. The electrode is immersed in 1 m, that is 1 molar HCl. That means 1 molarity HCl solution. H2 gas, platinum wire, platinum foil dipped in 1 m, that means 1 molar HCl solution. It contains H plus ion and Cl minus ion. This is the construction which is connected to another metal electrode. Therefore, circuit is completed. So that the circuit is completed, the value, this is fixed as arbitrarily 0 volts. The standard reference electrode here taken as standard hydrogen electrode, the value is fixed as arbitrarily fixed as 0 volts. Therefore, that is the standard hydrogen electrode. Next one, what are the reaction takes place when hydrogen electrode act as anode, when it is act as cathode? When it is act as anode, that means it loses electrons. When it is acting as cathode, it gains electrons. Therefore, here it is represented like this. PT, that means platinum wire, hydrogen gas at 1 atm pressure / 1 molar HCl solution, that is simply represented by H plus ion. PT H2 1 atm bar H plus 1 molar solution. In a cell, that means other part of the cell, in a cell, when it is, that means it is means standard hydrogen. This is normal hydrogen electrode or standard hydrogen electrode. Simply they called She means standard hydrogen electrode. When it is acting as anode, this reaction takes place. When it is acting as cathode, this reaction takes place. Thus the both anode and cathode it will act. Thus the electrode is reversible with respect to H plus ions. That is the construction of standard hydrogen electrode, and these are the reaction takes place when it is acting as anode, when it is acting as cathode. Here, that is, therefore, here it is acting as cathode. Here metal electrode acts as anode, that is the source of electrons. Therefore, from this connection, we calculate this metal electrode potential. Why? By using the formula E cathode minus E anode, it is arbitrarily fixed as 0 volts. Therefore, the potential obtained is because of this metal electrode only. When it is copper, or it may be a magnesium, or it may be another metal. Therefore, this is the construction. Again, one diagram. This is glass rod. This is platinum wire, hydrogen gas, 1 molar HCl solution. In the same way, it is represented. It is called standard hydrogen electrode. This is also called primary reference electrode. The electrode potential is found out by coupling the electrode with the primary reference electrode, the potential of which is arbitrarily fixed as 0. The important primary electrode is used as standard hydrogen electrode. Here, that is the situation where we have to find out the electrode potential values of all the metals. Primary reference electrodes are used. In that, SHE, she is also a primary reference electrode. These are the reaction takes place. Why we need here, sometimes SHE, she may be troubled. It will not give 100% results. Why? Because here there is a need for secondary reference electrode. Why? The use of she means every time standard hydrogen electrode is difficult, because it is difficult to maintain every time 1 molar H plus ion. This is somewhat better, but every time you have to maintain 1 atmospheric pressure. The electrode will get easily poisoned in case of traces of impurity in the gas. Any impurities in the gas causes some difficulty in producing the potential values. That means it is poisoned. Hence, other reference electrode is used as standard saturated calomel electrode. This is another reference electrode, saturated calomel electrode, that is saturated KCl with mercurous chloride. Saturated calomel electrode. This is secondary reference electrode, which is the best electrode. This in the case of She, some impurities get damaged the electrode. Therefore, the values are obtained or may not be 100% correct. Therefore, this standard secondary reference electrode is also used to obtain the potential values. Here, one thing. Okay, electrode potential completed. Here, the calomel electrode. What is the secondary reference electrode? That is called calomel electrode. Calomel electrode is most widely used secondary reference electrode. Why? Because when she is not 100% sure, the standard at the conditions maintenance is difficult. That means pressure 1 atmosphere, 1 molar HCl. This is used. The standard calomel electrode, it is SCE. How it is constructed? This is like that. This is a glass tube. This is comprises of wide glass tube fitted with a narrow side tube. This is one side tube. This is another one side tube. This is a glass tube. This is a glass tube. Therefore, I will explain by using this paragraph. Pure mercury is placed at the bottom of the tube. Here pure mercury is poured in this glass tube. Here two side tubes are there. Here one platinum wire is there. Platinum wire. Two side tubes are there. Here KCl solution. In that above mercury, mercury is placed here. Above mercury, mercurous chloride Hg2Cl2 and along with mercury. This is called calomel. Above that calomel, KCl solution is poured. KCl solution is poured via this side tube. This side tube is able to connect that metal electrode. To complete the circuit, this side tube is connected to another metal electrode. Okay, what are the electrodes? What are the reaction takes place here? A solution of KCl is introduced above the paste. A saturated solution, that means saturated KCl solution, may also be used. A platinum wire is sealed into a glass tube used to make electrical contact. The side tube containing KCl solution provides the salt bridge. That itself is act as a salt bridge which connects the electrode to another electrode. The calomel electrode is represented as Cl minus. Why? Because Cl minus KCl 1 molar slash mercurous chloride mercury. This is the representation of calomel electrode. What are the reaction takes place during the calomel electrode? Here, these are the reaction takes place. At anode, this Hg gives electrons, and then this ion Hg2 2 plus ion react with Cl minus ions, forming, that is the from KCl, forming mercurous chloride Hg2 Cl2. In the same way, in cathode, these two electrons are gained at the cathode. These are the reaction possible. Net reaction at cathode is Hg2Cl2 plus 2 electrons. This is finally decomposed as mercury and chloride ions. This is the calomel electrode is also reversible with respect to chloride ions. Therefore, its potential depends upon the concentration of KCl solution. These are the reaction. Here are the explanation for calomel electrode. The reactions at anode, the reactions at cathode. Here source of electrons, here gain of electrons. Therefore, here the electrode potential values. Here, these are the metal electrode potential values. Here it is standard reduction potential at 298 Kelvin. Standard conditions. Here lithium, potassium. Reduction means by taking electrons. That is called reduction potential. By connecting with reference electrode like SHE or SCE, standard hydrogen electrode or standard calomel electrode, the values are obtained or tabulated in the form of a series called electrochemical series. The values of electrode potentials are tabulated in the form of a series. That is, here the reduction potentials are values are increasing, minus 3.05, minus 2. The reduction potential values are, here it is called SRP, means standard reduction potential. Here at 298 Kelvin, that is the standard condition. Pressure 1 atmospheric pressure, 1 atm or 1 bar. Here the reduction potential values are increasing. Therefore, that SRP of lithium is equal to minus 3.05. From these values, we can pick out which one act as anode, which one act as cathode, whether two electrodes are connected. In this here, for example, zinc, this is the reduction potential value is minus 0.76. Here, for example, copper, here 0.34. Reduction potential value is more. That means reduction, copper reduced, zinc oxidized. Here, if you want zinc and copper, here which one act as anode, which one act as cathode, this electrochemical series will tell you. For example, we take zinc. Here the reduction potential value of zinc is minus 0.76, which the reduction potential value of copper is 0.34. Which one is more? Copper is more. Therefore, copper undergo reduction, where zinc undergo oxidation. If you want to connect both zinc and copper, there are so many applications for the electrochemical series. If time permits, and then do next session, I will explain in the next session. Thank you.